Hello, folks. So, welcome to part 27 of Learning Rust series. This is part of my 100 Days of Rust series. I'm on day 13, and let's get started with the next exercise. So, this was the previous one, move semantics. I'm going to put, I'm not done, like remove that, and then move semantics too. Awesome. So, borrow of mode value, move occurs because vec0 has type this, which does not implement the copy trait. Yep. Actually, I've never seen the error for this. Explain cat. Okay. Variable was used after its contents have been moved elsewhere, meaning the ownership has been moved. Struct. Okay. Actually, I've never used structs or period structs, but this is the first time. Okay. So 5 unsigned third bit integer, and then y equal to x. So this is a mutable thing. So this is a user-defined data type, and it's, I believe, allocated on heap and not on the stack. Um, is a type not that is not marked copy. The data gets moved out of X and then goes to Y. So the ownership moves from here to here. The same thing goes here though, and the reference basically goes here, and this is no longer the owner. And when we set Y, this is fundamental Rust ownership system. All sort of workarounds like RC. I don't know what that is. A value cannot be owned by more than one variable. Sometimes we don't need to move the value. Using a reference, we can let another function borrow, references borrowing and all that, without changing its ownership. In the example below, we don't actually have to move our string to calculate length. We can give it a reference to it with ampersand. So if we move it, you have to again return it to actually return back the ownership and all. Return reference can be created with ampersand mute, and then sometimes one moment, it's ampersand and then the name of the thing. So yeah. Oh wait, ampersand and then mute and then the name of thing. So mutable reference to mutate things like say modify the string itself. We don't want a reference but a duplicate. All types marked clone can be duplicated by calling the clone. Subsequent changes to a clone do not affect the original variable. Nice. In the channel library, I marked clone. For example, below demonstrates using clone on a string. Is the first set to many and then copy to S. Then the first character of S1 is removed without affecting S2. Any many is printed to the console. Okay, many, and then this is a clone, and then S1 dot remove any. So you have any many, right? Nice. So wait, there's more. If we control the definition of a type, we can implement clone on it ourselves with derived clone. Sometimes we have that have no ownership semantics at all and are trivial to duplicate. An example is integer 30 bit. Okay, so because it's stored on the stack. Now we don't have to call dot clone to clone them because they're marked copy in addition to clone. Implicit cloning is more convenient in this case. We can mark our own types copy if all the members are also marked copy. Okay. So all the members say of a struct is copy, then you can just mark it as copy. Implicit. So all the members are. So in the example below, we implement a point type because it only stores two integers. We opt out of ownership semantics with copy. Then we can let P2 equal to P1 without P1 being moved. Okay. So we have derived copy clone, kind of like inheriting. So alternative, if we don't control the struct definition or mutable shared ownership is truly required. You can use RC or ref call. Okay, what is ref call? RC new, ref call, new, struct, clone. This approach extends share ownership of the data via the RC reference counter. Okay. Oh, the share ownership. Two variables can share the ownership of one data. Okay. Essentially performs runtime borrow checking, ensuring that at most one writer or multiple readers can access the data at any one time. Okay. If you wish to learn more about ownership, then just start with the understanding ownership chapter in the book. Nice. I've read that before, so I'm going to leave it at that. So now we'll go here and go here and we're line 13, column 57. We're here, so vector new, fill vector 22, 44, 66. Mutate it, like move the ownership here and then get back the ownership here. And since you moved it, so vector 0 is not applicable, do not change the following line. Okay. Interesting. I can't remove this line. So value moved here, value borrowed here after move. Okay. So what I can do is I can pass a mutable reference. Can I? Instead of like moving the ownership. I don't know. Do not change the following line. Okay. Without changing line 13 or moving line 10. Okay. You should not move line 10. Okay. Don't change line 13. Okay. Interesting. Okay, I should not move it. Basically, I should not move it below this. Then that will work. It will just work because it will print this and then start it. So can I take a reference? I mean, can I do that? That way the ownership is not passed away and then pass a reference. Selected struct vec found. Okay, so reference expected because of return type. Try using a conversion method to vec. Okay, to vec. Okay, interesting. Variable does not need to be mutable. Okay, this is for 21. Okay, this one. Huh? Why shouldn't it be mutable? I'm doing push, right? Use unused mutation notifier can borrow as mutable as it is behind and reference. So consider changing this to a mutable reference. Okay, because makes sense. This is a mutable reference. So variable does not need to be mutable. Does not need borrow as mutable as it's not declared as mutable. Consider changing this to be mutable. Okay. So since vec has to become like a mutable thing, like this is immutable, then like mutable, and then you can just do. Wait a moment. Let it rerun. Okay, so mismatch types differ in mutability. An incorrect expected mutable reference found this. Okay. Oh, mutation of mutation. No. Interesting. Mutation of no. I should say mutable reference. Sorry, I'm being sleepy. Expected mutable. Then yeah. So now cannot borrow VC as mutable as it's not declared as mutable. Okay. Let's declare it as mutable because yeah. Awesome. So it works now. Cool. So I had to do quite some stuff. Now I understand what people mean by you have to fight with Rust errors, like Rust compiler errors. So I think it started off with like things going wrong here, like saying you should not change the following line, but this has moved, the value of this has moved. So I was like, how do I not move it? I can't remove this line or change this line. How do I not move it? You can move, like you can not move it by doing a reference or like borrowing, right? You can let the function borrow it. But if you let the function borrow it, it is a immutable reference, and then you get a mutable thing here. Can you actually do this? Can you create? Oh, no. Can you create a reference? Mutable reference. One moment. So 21. Can it be a mutable reference? I mean, that's all there is, right? It's a mutable reference. Oh, this does not say mutable. This is okay. So it has to be a mutable reference. And if it has to be a mutable reference, then I have to pass in a mutable reference for which this has to be mutable. Or else it will fail. Cannot borrow is mutable as it's not declared. So you can't borrow this is mutable. Borrow reference is mutable reference is not mutable. Declare is mutable. So mutable. That's all. Awesome. So are there any Rusty is wondering, are there any warnings that I'm missing? I'm just gonna go ahead and check that out. Copy relative path. Awesome. So there is a warning. So variable does not need to be mutable. Okay. 21.9. Help remove this mute. Okay. 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 So this is understood that it's a immutable variable thing. Okay. Awesome. That's all. No other things. Let's do this and then say finish move semantics to exercise and then clean up this binary and we're good to go. Cool. So that's all I had for this video. I'll see you in the next one. Bye bye.